Welcome back to the deep dive. So if you've ever had the dubious pleasure of wrestling with a traditional AV matrix switcher.
Oh, yeah. The ones with all the specific cables?
Exactly. Fixed inputs, fixed outputs. Scalability is basically, well, a nightmare.
A mess of hardware limitations, for sure.
Today, we're taking a deep dive into something different, an architecture that's really changing how high-res video gets managed.
We're looking at sources on these advanced AV distribution systems.
Specifically, these 4K 30 Hz AV over IP matrix switchers, like the WolfPack examples we dug up.
Right, they might start small, maybe handling, say, 10 TVs.
But the whole point, the mission, is they scale, almost infinitely it seems, using standard IP networking. So our goal today isn't just, listing features, it's understanding that fundamental shift.
How they actually use network rules for video.
Yeah, and what are the must-know facts? Performance, cost, control.
Yeah.
What makes these better than the old way?
And our sources, they give us that technical blueprint. We've got hard specs, performance numbers.
Application guides too, right? Practical stuff.
Exactly. We can use those numbers to explain the why behind the tech. Like, why 4K at 30 Hertz? That's a really key decision.
Okay, let's definitely unpack that. So starting with the basics, this architecture, AV over IP. What does that actually mean here in this professional context?
Well, fundamentally, AV over IP means your high-res video signal isn't on its own special cable anymore. No proprietary copper or fiber just for video.
Okay.
It gets converted into data packets, like any other network data.
And sent over standard network gear, like a regular Ethernet switch.
Precisely. That's the core change right there.
And the power over Ethernet part, PoE. How significant is that in these designs?
Oh, PoE is a huge practical plus. Power over Ethernet means those little boxes, the extenders near your source or TV,
Yeah.
they don't need their own power brick plugged into the wall.
No, okay.
They get their electricity straight from the network cable, the Cat6 cable, that's plugged into the PoE Ethernet switch.
So that simplifies the install quite a bit.
Massively cuts down wiring clutter, fewer things to plug in, fewer points of failure. It just makes the physical setup much cleaner.
Okay, that makes sense, streamlining the physical side. But the sources mention a really specific technical point. These systems run 4K video, but at 30 frames per second. And crucially, over a standard 1 gigabit switch. Why that combo? Why not 60 Hertz, which sounds, better?
That 30 Hertz spec, that's actually a really smart engineering compromise. It's designed to save you a ton of money.
How so?
Well, if you try to push uncompressed 4K video at 60 frames per second, the full fire hose,
Yeah.
you need really expensive high bandwidth 10 gigabit Ethernet switches. The infrastructure cost jumps way up.
Okay. 10 gig switches are definitely pricier.
Right. So by using efficient compression, they mention H.265 in the specs, and capping the frame rate at 30 Hertz.
To keep the data stream smaller.
Exactly. Small enough to run reliably over common, much more affordable 1 gig Ethernet switches. That choice makes the whole solution viable for places like sports bars, restaurants, offices, places that need lots of screens but are budget conscious.
Got it. So that cost argument is crystal clear. You trade maybe a little bit of ultra-smooth motion.
Which honestly, for things like TV shows, static menus, most presentations, you probably won't even notice.
Right. You trade that slight difference for huge savings on the network backbone.
Precisely. And this idea of standardization, it goes further. It applies to the components themselves. This is where I think the sources point to some real innovation.
Let's say.
The system uses just one single physical box, one type of extender unit.
Okay.
For both the transmitter, the TX that connects to your source like a cable box.
And the receiver, the RX behind the TV.
Yes. It's the same piece of hardware.
Wait, really? So you don't buy specific input boxes and output boxes?
Nope. You buy one type of unit, you plug it in, you go into the software, and you just tell it what job to do. You're a transmitter today, or you're a receiver.
It's really clever.
It fundamentally changes things for installers, for inventory. They only need to stock one part number, one SKU.
Cuts down on stocking risks, speeds up deployment potentially.
Absolutely. It's a big logistical win.
That makes sense.
Yeah.
And you mentioned the sources talk about pretty large setups, like 14 inputs and 32 outputs.
Yeah, a 14 by 32 matrix example, all running off one PoE Ethernet switch, controlled by a tablet or PC.
And the physical connection is just standard CT6 cable, running what, up to 450 feet?
That's what the specs say.
It's kind of amazing how much scale they're getting out of standard IT gear. Okay, let's shift focus a bit from the infrastructure to the actual user experience.
Right.
When I hear IP distribution, sometimes I think of like buffering or lag.
Yeah.
But this is for live video. How fast is it? Is there a noticeable delay when you switch sources?
Yeah, in these pro environments, latency is critical. You
Yeah.
can't have lag.
Right.
The sources quote the switching latency at just 80 milliseconds.
80 milliseconds. How fast is that, really?
Well, put it this way. Typical human visual reaction time is maybe around 250 milliseconds.
Okay.
So at 80 milliseconds, the delay when you switch from one camera feed to another or one channel to another,
Yeah.
it's basically invisible. You won't perceive it.
That's crucial for, say, a sports bar. You want that channel change to feel instant.
Exactly. Or for control room operators monitoring live feeds, instantaneous switching is key.
Okay, so the performance is there. But here's the really big claim I saw. Unlimited scalability.
Mm-hmm.
Now, historically, with a hardware matrix, you buy an 8x8 or a 16x16, and eventually you hit a wall. You run out of ports.
The chassis limits you.
Right. This tech seems to promise, well, getting rid of that limit entirely. Is that really true? Is it actually unlimited?
It's effectively true because the bottleneck isn't the physical box anymore, it's the network itself.
Yeah.
Since the video is just data packets on your network, you add more capacity by just adding more endpoints, more transmitters, more receivers.
And connecting them to the network switch.
Exactly. The sources explicitly say unlimited sources, unlimited HDMI ins and outs.
And they mentioned computers too, USB and KVM.
Yes. Unlimited computers, USB and KVM. That KVM part keyboard, video, mouse control is huge for businesses.
Like that.
It means you can have all your source computers or media players tucked away in a central rack and control them remotely from a different location, maybe a control desk, using the same system. No need to walk over to the rack with a keyboard and mouse.
Okay, that's a powerful integration. And how do they achieve this unlimited scale physically?
The system supports cascading multiple Ethernet switches.
So you don't need one giant, specialized, expensive switch.
Nope. You can just use standard network switches and link them together as your needs grow. Add another switch, connect more endpoints.
That really delivers on that promise of any in to any out any way you want.
Yeah.
You're just telling the network where to send the data.
It's all software-defined routing.
Okay, so if you can scale to potentially hundreds of inputs and outputs, controlling that must be critical. How do you manage that potential sprawl?
The control has to be flexible. It's fully software-based. You can use Wi-Fi apps, specific iOS or Android apps, or just control it from a PC.
So operators can use whatever device they prefer.
Right. Giving them options is key for smooth operation.
And there was one control feature that really jumped out at me from the sources, the iPad real-time video preview.
Ah, yes. That's a fantastic feature for usability.
Explain that. What does it let the operator do?
Instead of having to guess what's playing on source 3 or switching a random TV just to check.
Which can be disruptive.
Totally. The control interface, like on an iPad, shows you small, live, constantly updating video thumbnails of every single input source simultaneously.
Wow. So you see what's on every channel or camera feed right there on your control screen.
Instantly. You know exactly what you're routing before you route it. It saves a massive amount of time and prevents mistakes, especially in fast-paced environments.
I can see that being incredibly useful. Okay, let's talk applications. How does this flexibility handle more complex setups, like video walls? Those used to need really specialized, pricey gear.
Right. Video walls are a great example of where this IP approach shines. The sources say this system supports multiple video walls.
Any size, any number of them.
Any size and any quantity is the quote. And it's described as unlimited field upgradable.
What does field upgradable mean there?
It implies that the complex processing needed to split one source across multiple screens in a video wall layout. That's not done by dedicated hardware anymore.
Like a software.
It seems to be handled purely by software running on those standard transceiver units we talked about. So if you decide later you want to add a 2x2 video wall,
You don't need a new box.
you likely just need a software license update or configuration change for the units you already have connected to those 4 screens.
That really protects the initial investment then. You're buying hardware that can gain new capabilities over time.
Exactly. It's future-proofing through software.
And for serious commercial installs, security and compliance must be factors. What do the sources say about that?
They tick the boxes. SEC security compliance is mentioned,
Okay.
and adherence to the usual video standards like HDCP 1.4 for content protection and HDMI 1.4 compatibility ensures everything works legally and securely.
And a detail the finance department will like.
Ha, yes. A big one. No monthly license fees mentioned.
So you buy the hardware, maybe the software features like video wall capability.
And that's it. The ongoing cost is just your network infrastructure, electricity, no recurring software subscription for the basic operation.
Okay, let's make this even more concrete. Walk us through that optional sports bar system example they described. That seems to tie a lot of these control features together.
Yeah, the sports bar example is perfect. It shows how the system becomes more than just video routing. It's a full command center.
So if you're the manager with the iPad, what else can you do besides send source A to TV B?
The control package can actually integrate with the source devices themselves, like your satellite receivers or cable boxes. Meaning, right from the control app on the tablet, the manager can change the channel on the DirecTV box, the DSH box, the cable box, even a Roku.
Without juggling a bunch of different physical remotes.
Exactly. No more pile of remotes. You don't just say, send source 1 to TV 5. You might tap on the Lakers game icon and drag it to the icon representing the patio TV.
And the system does what?
It handles both switching the right HDMI input and sending the command to the DirecTV box to tune to the correct channel for the Lakers game, all in one action.
That's incredibly efficient.
And to make it intuitive, the sources say it can show the venue's actual floor plan on the iPad.
So you see icons for each TV laid out like they are in the real room.
Yes, and it shows the TV listings too, so you're not trying to remember, is TV 12 connected to port 7 on the switch? You just tap the TV on the map.
That gets rid of a huge operational headache right there.
It's designed for how people actually think about the space, not abstract port numbers. And critically, they also mention the separate audio outputs and control.
Meaning you can manage sound separately from video.
Right. You could send the main game audio only to the speakers in the main bar area, while maybe playing background music in the restrooms or dining area, all controlled independently from that same iPad interface.
That takes a really complex job and simplifies it down to tapping on a screen. Amazing.
It really streamlines operations.
Okay, finally, let's just touch on the pricing and configuration. How does that reflect this standardized approach?
Well, since that transceiver unit is the core building block, the pricing is modular. The sources indicate that one of those dual-purpose TXRX units costs around $250, which enables that build-your-own-system idea. You basically just buy as many units as you need, endpoints, inputs, plus outputs.
So the initial cost can be quite low if you start small, and it scales up predictably.
Exactly. And for people who prefer ready-made packages, they listed examples too, like a small 2x2 system around $1,975.
Okay.
Up to something larger, like a 6x10 configuration for about $4,975. The cost tracks pretty closely with the number of endpoints you need.
It makes sense. So summing up this deep dive then, we've looked at a pretty robust, modern way to distribute AV.
Definitely. Using that cost-effective 4K 30 Hz over standard 1 gig networking.
Leveraging PoE for simpler, cleaner installs.
Right, and delivering video with that really low, almost imperceptible latency, just 80 milliseconds.
But the really powerful ideas seem to be the software-defined parts.
Yeah, that single piece of hardware acting as either transmitter or receiver.
That's a game changer for inventory and flexibility.
And the truly unlimited scalability, just by adding to the network, takes away that future expansion anxiety.
Okay, but let's leave our listeners with a final thought, building on that specific detail, the dual-purpose hardware.
Right. The fact that the physical box, the transceiver, is now standardized, relatively inexpensive. And its entire function, its personality, is defined just by a software click. That's more than just convenient. It's kind of revolutionary for the pro AV world.
What does it signal, do you think?
It tells us that the value in this industry is shifting dramatically, away from complex, specialized, single-purpose hardware.
And moving where?
Entirely into the software layer. The intelligence, the features, the control. It's all becoming software running on more standardized, almost commodity hardware.
And the implications could be broader than just video.
Oh, absolutely. Think about it. This could be the model for how all sorts of building systems get managed in the future. Security cameras, access control, lighting, HVAC.
All running over standard network infrastructure.
Standardized physical gear, maybe PoE powered, all configured, controlled, and scaled up purely through software platforms.
The ultimate move from buying lots of different boxes to buying into a software-driven platform.
Exactly. A fascinating glimpse into where things are heading.
Indeed. Well, that's all the time we have for this deep dive. Thanks for joining us.
We'll see you next time.